Lesson 4, Basic RV Electricity. Topics here we're going to cover are wiring colors and the nightmare of confusion, safety, the introduction to electricity, non-contact voltage testers, basic info of a multi-voltmeter. We're going to talk more about batteries, multiple battery setups, and how to check a campground pedestal. Wiring colors and the nightmare of confusion. So there can be a massive amount of confusion when dealing with RV electricity and wires. Take a look at the info that you're looking at there. You've got 120 volt AC, 30 amp, 15 amp systems. You have three types of wires, or three colors of wires: black, white, and copper and green. The black is hot, it's the wire carrying power. White is neutral, copper green is ground. Now, you got a 50 amp RV, you throw red into the mix also. You've got black, white, copper green are the same, but now we've added a red wire, which is also carrying power. So what you have is very few out there. 99.9% of RVs out there operate off 120 volts. I don't care what the label says on the side of your RV. It is not 240 volts. It is two lines of 120 volts. Now, that being said, for those that are familiar with automobile wiring, if you looked back at what we had with a 50 amp, you had both black and red wires, as well as white and copper or green. Talking about 12 volt DC battery wires, right? Using normal wiring, you have red and you have black. Also with 12 volt DC, you could possibly have commonly used AC wiring, which happens on travel trailers quite often. You will have black and you have white. What you have here with red and black is red is normally positive, black is negative. Now, you have black and white. Black goes to the positive side of the battery and white goes to the negative side, also known as the ground. Now you can start to begin to see why I labeled this wiring colors and the nightmare of confusion, because it gets really, really bad in confusing people, and it makes it so confusing for new people who might recognize red and black, and now they've got black and white. It's easy for them to go, okay, it's black, that must be negative, and put that on the negative pole, put the white on the positive pole, and now you've got yourself a reverse polarity situation. You've hooked a battery up backwards, and your converter doesn't really appreciate that. So, what you now have is this big mess in how it can confuse those new to RVing. So, as I said multiple times before, take a picture of what it looks like, your battery wire setup, before you start disconnecting your wires, right? I cannot stress this enough. Everybody has a phone nowadays. Well, almost everybody. Take a picture of what it looks like before you start removing wires. It just will save you a lot of headache in the future. I'm going to reiterate this multiple times. In one environment, black is hot. In the other environment, black is ground. Black is hot in 120 volts AC, potentially, if you have black and white wires. Black is ground if you have red and black on your 12 volt DC in your batteries. Depending on which RV manufacturer did the wiring, the wires to the 12 volt DC battery could be red-black or black-white. Just want to make sure you all keep that in mind as you're looking at your particular RV. How do we know which one is the ground and which one is hot if you forgot to take a picture first? All right? If you don't have a voltmeter yet, get yourself one. Right? The reason you want, this is one of the ways you can determine. Pull out your handy dandy voltmeter, right? If you don't have one, go to a big box store. You can go to store.rvingfornewbies.com. I have them on there. The link's right to Amazon. You can check the rvfn.net website, which is the shorthand version. Right? Go and get yourself one of those voltmeters. Now, in your battery world of your RV, the negative ground pole wire goes to the frame of the RV. So how does this help? If you have two wires, checking out your voltmeter and how it works, figure out which one of your settings is to check for continuity. Because what you'll do is you'll take one probe and put it on the wire, and one probe, put it on the frame of your RV somewhere. If you get continuity between the two of them, that is your ground wire. Now, just to be safe, you should take the probe and put it on the other wire and keep the one on the frame of your RV. And then you can see if that one is doesn't have any continuity, that is your positive wire. Story time. Okay, so I was working at an RV dealership. We were having to wire in some new batteries. There were literally 8 wires on each pole of the battery wired in. Red, black, white, blue, green, yellow, and purple were the colors, with evidently some of them duplicated on each pole. The easiest thing to do was I pulled out red electrical tape. I taped up all of the wires that were hooked up to the positive pole of the battery with the red tape. Then I took all of the wires that were hooked up to the negative pole of the battery and taped those up with black tape. That was before removing them from the battery. So when it came time to swap the new batteries in, we knew exactly which wires went to which pole. So that might be something you might want to contemplate for your own RV. Safety. When working with 120 volts AC, turn off the auto start of your generator if you have one. Some people have generators that if the power goes out on the pedestal or you unplug the shore cord, your generator will automatically start up. Turn that off. Turn off the breaker at the pedestal, unplug your shore cord from the pedestal, and put the cord away so nobody accidentally plugged it back in while you're working on things. 12 volt DC. Turn the battery disconnect switch so the battery's disconnected. Make sure you are unplugged from shore power so you don't have 12 volts being fed from the converter to your battery. Remove the negative wire from the battery. Notice I didn't say the black or the white wire due to the confusion that we talked about in a previous part about wiring colors and nightmare confusion. Look at the poles of the battery. See which one is negative. Remove that wire first. Introduction to electricity. 2 types. So we're going to talk a little bit about 12 volt DC and 120 volt AC. So 12 volt DC is the most important between the two of them for a few reasons. 90+% of everything in your RV requires 12 volts DC, which is also known here as battery power. From most lights, water pump, appliance control boards from your refrigerator, furnace, thermostat, your slides, your leveling system, the list goes on and on. Those are the things that will need battery power or 12 volt DC. 120 volt AC is needed for your big draw items. Air conditioners, coffee makers, your microwave, and the electrical aspect of your water heater. So how do we get 120 volts AC and 12 volts DC to our RV? 120 volts AC, also known as commercial power, comes through your shore power cord, your generator, or an inverter. 12 volt DC comes from batteries and your converter. So how do we change between the two? If you had 120 volt AC or 12 volt DC, and how do we switch it to the other format? So 12 volt DC to 120 volt AC. To go from that, it is done by what's known as an inverter. Not everybody has an inverter in their RV. I do not have one in mine, but I do understand how they work. There are 2 types of inverters, a pure sine wave and a modified sine wave. Your electronic items like computers, things of that sort, appreciate pure sine wave. Pure sine wave inverters are more expensive, no doubt, and they are larger. Now, how can you tell the difference? Well, when you look at one, they will usually tell you if it's a pure sine wave inverter right on the label, printed on the inverter itself, the documentation, it will tell you. Now, depending on the type of voltmeter you purchase, it can potentially show you whether an inverter is pure or modified sine wave. And amazingly, the cheaper ones will show you that. The more expensive ones, also known as true RMS ones, will not show you. So I produced a video showing with a cheaper voltmeter and a more expensive one, so you can see how it detects pure versus modified sine wave inverters. The link will be there in the notes for this lesson, and you'll be able to go and take a look at the video. But if you want to type it in, it's https://vimeo, vimeo.com/RVing for newbies, RVINGFORNEWBIES/inverters. So how do we change from 120 volts to 12 volts DC? Well, almost all of you that have a converter in your RV, that takes your 120 volt AC coming in from your shore power or from your generator, and it will convert that to 12 volts DC to charge the battery as well as supply the 12 volts you need through the rest of the pieces in your RV. Protective devices. So 12 volts are protected mostly by fuses. Some are resettable, but there are an occasional time where a breaker is used. 120 volts AC, they're all breakers. So circuit breakers are found in your power distribution panel and can be reset, but have a limited number of times they will trip and can be reset, and that number is mostly unknown. But if they start tripping all the time, it may be a good idea that they need to be replaced. Fuses, covering your 12 volt DC side, they're usually one time. It's blown, you got to swap, you got to fix the problem, swap it out. So keep extras on hand. They also do make resettable fuses. I have a handful of those that I use. If you have, I'm helping someone, say, debug an electrical issue and it's popping fuses like crazy, we'll put a resettable one in so we don't go through a whole bunch of fuses. GFCI, ground fault circuit interrupter. They're usually found in your bathroom, kitchen area. You can see and tell by looking at the receptacle, there's usually a button and a light involved. Now, keep in mind, they could be daisy chained together, which means if one trips, they could all potentially need to be reset. Now, how is this a big deal? I've seen some RVs where if you trip the outside breaker, the GFCI, it could pop the one in the bathroom or vice versa. So you may reset one in one place, or maybe it won't reset because you got to go reset one further down the line or further up the line. So just kind of keep that in mind. Your RV, instead of the GFCI outlet, it could have a GFCI circuit breaker also. So keep that in mind. Know what you have in your power distribution panel if you happen to have a GFCI breaker. Let's talk about your converter. So your converter takes 120 volts AC and it converts it into 12 volt DC. That has two main purposes: to charge your batteries. Usually it's just the house living space batteries, but not normally your engine battery. But if you have a motorhome, like usual, it depends. It may charge those also. Second thing it does, it provides 12 volts DC for things in the RV that need it, like lights, control boards, igniters for propane, slide motors, the list goes on and on. Probably one of the most important things is it has two reverse polarity fuses. They're usually either 30 or 40 amp depending on the converter. In the event you swap out the battery and you put the wires back on backwards, those two fuses will blow in the converter. And that's used to protect the converter in case you hook it up backwards, the wires. So let's talk a little bit about a story. We'd already talked about the black and white wire shenanigans and the nightmare of confusion. So here's a little bit of a side story. Someone calls me about their batteries going dead. So they replace them and they still won't charge. So I do some investigation. There's no voltage going to the batteries from the converter. Looking at the wires to the battery, it appears the black was put on negative and the white was put on positive. Or if you remember our discussion with wiring colors and the nightmare of confusion, the individual had taken the black wire, assuming it was ground, because if you have red and black, that's usually the way it is. But since they had white and black wires going to the battery, they hooked up the black to the negative to white to the positive, and boom, they had it backwards. So the reverse polarity fuse is in the converter in blue, which means no more charge in the battery. So I went through, disconnected the wires from the battery, taking the negative off first, of course. Then we replaced the fuses, put the wires back on correctly, and we were back in business with the converter charging the battery. So did they replace the batteries and then hooked it up backwards? Don't know. But the whole concept is to make sure you understand which is positive and which is negative. But even if you blow it, keep a couple of 30s or 40 amp fuses on hand just in case somebody hooks it up backwards. Non-contact voltage tester. So what is a non-contact voltage tester, also known as NCVT? It is a device you can use to detect electricity without using a multivoltmeter. Why would you want to do that? As you'll see in our next topic, we'll be covering checking a campground pedestal before you plug in your RV. It is an amazingly simple tool to use, fits perfectly for this class, and you'll see use for it coming up shortly when we get to a campground and we're checking the campground pedestal. We want to check it even before touching it with our hands. Keep in mind, this tool will tell you if there is voltage, but not how much there is. Voltmeters, multimeters. I would think every one of those out there can measure both AC volts and DC volts. The symbols can be confusing to those who have never used one, so let's cover those two first. AC voltage, which is what you have in your house and the receptacles in your RV, is usually a V with a wavy sign over it. DC voltage is usually a V with what looks like center lines down the highway, with one side being allowed to cross the yellow line and pass other vehicles, also known as one solid line and one dotted line. Based on what we talked about before, I write on my multimeter, so I don't have to think about it. AC, DC, since that's the majority of what I check. This one does way more than AC and DC volts. It also does amps, ohms, continuity, as well as temperature. But when I'm looking at mine, I don't have to think about it. I just go, oh, we're going to do AC. We switch the little arrow thing to AC or to DC. Basic info of a multivoltmeter. We're going to check two things. 12 volt DC battery voltage, and we're going to check electrical voltage of 120 volts AC. Now, some safety. When working around electricity, it was mentioned earlier, be sure you know which is the positive and which is the negative pole on the battery for 12 volts. Not that it will matter on the meter, it will still show you the voltage, but it will show it to you with a minus sign in the front, telling you that you have the leads backwards, but it's a good habit to get into. What you see here is a small, simple battery from a UPS. Just to show you what checking a battery looks like. This one is 13.18 volts. Very simple. Red probe on the positive, black probe on the negative, and your readout on your voltmeter. If things are acting crazy in your RV, get out your voltmeter and check your battery voltage. We're going to look at voltage charts here momentarily. But if things are starting to act wonky, right, the batteries are the first thing I check because the 12 volt DC is so throughout the RV for control boards and just it goes on and on and on. So when things start acting stupid, definitely check your batteries first to make sure that they're not dying. This is your typical 120 volt outlet, if wired correctly. The small slot on the right of the two slots is the positive hot one. If you put your probes in backwards to that, it will still show you the voltage on your voltmeter. How did I know if the smaller or the bigger one is the hot wire? You can use a polarity checker to tell you if it's wired correctly. You can also put the red probe in the smaller one, the black one in the ground. It should still show 120 volts or somewhere in that vicinity. If it is in the big slot on the left, which is the neutral, it will not show 120 volts. It still might show some voltage, but not anything near 120 volts you'd expect to see. So, to recap, as you look at the second picture there with the probes, the smaller one on the right is red, the big one on the left, which is your neutral, it goes to black. You should see 120 volts. If you take the black one, move it to ground, which is the half moon-like thing on the bottom, you should still see 120 volts. Now, if you take the red one, put it into the left slot, and the black one into the bottom, you may see some stray voltage in there, but you will not see 120 volts. I repeat this quite often as it is important to remember. You must keep in mind that when you're hooking up wires to a battery, there are two wires. If it is black and white wires, and this is usually on a label on the RV somewhere, like the tongue area on a travel trailer, where the label is telling you that black goes to positive and white goes to negative pole on the battery. If the wires are red and black, normally red goes to positive, black goes to negative, but as stated above, taking a picture of your setup right now so you have it for the future. Let's talk about disconnecting and connecting battery wires. The first thing you want to do is look to see if your RV has a battery disconnect switch and move it to the off position, meaning we're going to disconnect your RV from the battery. As you look at the battery, look at which pole of the battery is the negative one. That is the cable you want to remove first. After you've removed the negative cable, move it out of the way, so it cannot accidentally touch the negative pole of the battery again while you're touching and disconnecting the positive side of the battery. You don't want sparks, and you don't want to get shocked by batteries. People will talk about it. I can grab both poles, and I don't see any sparks, and I don't get shocked. So why all this safety stuff? It does not take much electricity to stop someone's heart, and for some of us, even less, which can lead to a cardiac arrest, also known as a heart attack. There are several types of batteries. The most common is known as the flooded cell battery. These are batteries with acid in them, and they require maintenance. You must keep the water level in those batteries maintained to the top of the cells. They have removable caps, and you must fill them up with distilled water. There are also AGM and lithium type batteries. Motorized RVs, motorhomes that are known as Class A's, B's, and C, you have two batteries at a minimum, the house battery and the chassis battery. The chassis battery is for the engine part of the motorhome. Towable RVs, travel trailers, fifth wheels, pop-ups, you have one battery location just where the house battery is, but there could be multiples in that location. Be sure to look at the positive and negative when disconnecting and connecting wires from your batteries. Even better, tape the wires, especially if you have multicolored wires, with black electrical tape for negative pole, red electrical tape for positive poles. As you look at this picture, there are two 12-volt batteries hooked up in parallel, which we'll talk about soon, parallel, serial, multiple battery setup. But this gives 12 volts to the RV, but having them hooked up in the way they are gives longer running time before they would have to be recharged, also known as having more amps. This is the voltage chart for lead acid and AGM batteries. You do not want to drop your voltage to your battery to less than 50%. And you look at the chart, you see that is at about 12.06 volts. As 50%. If you start dropping your voltage in your batteries to lower than that, you begin to start damaging them. Here is a voltage chart for lithium batteries. Notice it is totally okay to drop them to 0%, which is about 10 volts, without prematurely aging them. Lithium batteries cost a lot more, but it's just something you could entertain the idea of. We're going to talk about multiple battery setups, parallel and serial. So if your RV has more than one battery with what looks like wires going everywhere, you could have a parallel or a serial setup. The end goal here is to give 12 volts to the RV in either setup. So what kind of setup you think we have to the right here? What we're looking at is a parallel setup. This is two 12-volt batteries. Notice the positive wire is to the positive wire on each battery, and same for the negative. And then wiring to the RV. Here you get twice as much run time, but you get the same volts, which is 12 volts. What is the setup we have here on the right? This is two 6-volt batteries. Notice one wire from the positive is to a negative wire, and the rest of the wires go to the RV. This gives us 12 volts to the RV. It is a serial setup. The voltage is added together in the serial setup. Some of you might have 4 batteries or more. Those setups are a bit more complicated, but it's just a combination of serial and parallel setups to produce 12 volts. The next subject we're going to do is talking about checking a campground pedestal. Do you check the campground pedestal when you get to the campground and before touching it with your bare hand and plugging in your RV? My guess is probably not. Not very many people do, but these next set of slides will cover how to go about doing that. Equipment needed, you need at a minimum a non-contact voltage tester. Optional equipment is either a 30 or a 50 amp circuit tester if you don't have an electrical management system. So we'll talk a little bit about those pieces, parts. Electrical management system, if you can afford it, it's definitely the better way to go. All right, so here are the steps on checking a campground pedestal. Number 1, do not touch the campground electrical pedestal with either hand. Number 2, turn on the NCVT and have it in either hand. Number 3, while using the NCVT, touch the outside of the pedestal box, the tops, the sides, and the bottom, especially where you're going to grab it. While using the NCVT, touch the front door of the box. That will give you access to the inside of the cabinet. The NCVT should not beep. Put your open hand into your back pocket or behind your back. You're going to do this as a safety thing. Why? Your hand could clamp down on the case, muscles tension up, and they tighten up when electricity goes through it. And you don't want to be able to be in a situation where you can't let go of the box. Using the back of your other hand, touch the front of the box. Feel if any tingling. You should not. Next step, now you may open the box. What do you see in there? Do you see circuit breakers? Yes or no? So this is where we're going to split off. If you see circuit breakers, continue with step 10. If not, we're going to continue on to step 11. So for step 10, look at the breakers inside. Are they all off? If yes, while not touching the outside case door, turn them all on and do the test from step 3. Again, using the NCVT to touch all around the box, listening for the beep to denoting any stray electricity. Be sure to touch the cover also. Once done, if you got no beeping, turn off all the breakers, go to step 12. If you're here at step 11, that means there's no breakers in the box. So they're located elsewhere and are probably already on. So since you tested the box, it should be safe. This is an unfortunate situation. Why? If you were to trip a breaker, you will then have to contact the campground staff to get it reset. Step 12. Do you have an electrical management system and EMS? Yes. Make sure the breakers are off, if they're in the box, of course. Plug in the short cord to your RV and turn the breaker on. You're done. The EMS will do the evaluation of the receptacle for you. You can skip the rest of the steps coming up. If you don't have an EMS, we're going to go to step 13, but you should definitely consider getting an EMS. Feel free to reach out and I'll tell you why. Step 13, pull out your 30 amp or 50 amp circuit tester, plug it into the appropriate receptacle, turn on the breaker, and look at the lights to see if the receptacle is wired correctly. If wired correctly, turn off the breaker, plug in your RV, turn on the breaker, and you're done. Step 14, if you don't have one of those circuit testers, you can do a partial test using your NCVT. Taking your NCVT, checking of the receptacle with the breaker on. Take it, look at the picture here. There's a 30 amp receptacle on the left with an L pointing to one of the holes on the receptacle. And if you have a 50 amp receptacle, you have both an L1 and L2. Right? Those are the ones you're going to want to put the NCVT in to start with to see if there's electricity. All right, you should see electricity L1, L2 on 50 amp, and L on the 30 amp with the breaker on. Next, you're going to test the N, the neutral hole. For the 30 amp, it's off to the lower right. For the 50 amp, it's the one on the bottom. Last, you're going to want to check the ground hole. The G, which is the top half moon-like thing on a 30 amp, it's at the top, and it's also the same on the 50 amp. It's at the top. If you find any of those that beep when they should not, or do not beep when it should, you'll want to stop at that point, contact the campground staff to come out and check the receptacle. If it's good, plug in your RV, turn on your breaker, and you're ready to go.